Hi, in this lesson you're going to learn about the cosine law. Now you've already learned about the sine law, and the sine law works for any kind of triangle, as the cosine law does, by the way. Remember that capital letters are vertices and small letters are side lengths. Sine law works when you have an angle and a side across. You have to have that pairing, or else you can't use the sine law. When that happens, you use the cosine law. So I'm going to develop the cosine law for this triangle at right, ABC, with sides as labeled and an altitude of h. First of all, I'm going to look in triangle number 1, and I'm going to do Pythagorean theorem. B minus x all squared plus h squared equals c squared. Isolating for h squared, I get c squared minus b minus x squared. Triangle 2, I'll do the same thing. X squared plus h squared equals a squared. I'll isolate for h squared again. I get h squared equals a squared minus x squared. Now, h is an internal construction that I'm not really interested in, but I use it to make a relationship here. I'm going to relate these two equations. Because they both equal h squared, I can say that the right side of each equation is equal to each other. Let's expand the left side. I get b squared, I get 2bx minus, and a minus, so plus 2bx. I get x squared being subtracted. And you can see that I have a common x squared term being subtracted. I can remove that by adding x squared to both sides. Now, from triangle 2, let me use a cosine relation. The cosine of angle C is equal to the x value there on the bottom compared to the a. Isolating for x, I get x equals a cos C. And again, x is a construction that I use temporarily just to relate variables. So I'm going to substitute this relationship into the equation up above. I get c squared minus b squared plus 2b. There's your x, a cos c, and it equals a squared. So no more h, no more x. Everything's based on a's and b's and c's, which are the values that I'm actually interested in knowing about. Now I'm going to, pardon me, I'm going to isolate the c squared term. I will get c squared equals a squared that I already had on the right. I bring b squared over by addition, and I'm going to subtract this term, so minus 2ab cos c. Now, that is a version of cosine law right here. It's a different relationship between sides and angles, and you notice that it uses cosine. That's why it's called cosine law. There are variants of it. There's really nothing special about a and the b and the c. Notice, though, that the isolated side matches with a cosine of the angle across. So I could similarly write a squared equals b squared plus c squared minus 2bc cos a, etc. Another thing I'd like to observe is solving for an angle. So if I solve or isolate for angle C, I would have, let's move this term to the left side, 2ab cos C equals a squared plus b squared that stay on the right. C squared moves to the right side. I'm going to divide by the factors in front of cos C. I have an extra c there. Just ab cos c. There we are. A squared plus b squared minus c squared divided by 2ab. So if you want to isolate for the angle and solve for an angle, that's a version of the cosine law. By the way, something I'd like you to just think about in this first version of the cosine law, what happens if angle C equals 90 degrees? And I'll leave you to think about that. All right, I want to use cosine law to solve two different triangles, or at least start to do that. Example 1, I'm going to give you angle A 35. I'm going to give you side C 4, and I'm going to give you side B 7. Now you'll notice that I don't have a pairing of angle with side across, and I'm not able to easily get that, so this is a candidate for cosine law. Let's solve for side A, because I know angle A. A squared equals B squared plus C squared minus 2BC cos A. Substitute the values and see what you get, then rejoin me. Okay, I substituted values for B and for C. Notice that when you see B squared, C squared, you'll also see BC in the next term. Cos of A, this is not a special angle. We're going to need our calculator. The result you get is for A squared. Don't forget to take the square root. So that's the length of side A. See, now that you know side A and angle A, you could now use sine law to get angle C or angle B and finish solving the triangle. Here's another example. Example number 2. Now what's different in this case is I gave you no angles at all. So we need to solve for an angle. All right, let's use the version of this cosine law that I wrote up above right here. Cos of an angle are the sum of squares of the other two sides, then we subtract the side opposite the angle and divide by twice those values. So let's say I want angle F. I would say the cos of F equals d squared and e squared. So I start with the other two. Then I subtract the opposite side, twice de. Notice it doesn't always have to be an ABC triangle, right? This works for any letters. Cos of angle F then is 4 squared minus 6 squared, plus rather 6 squared, minus 3 squared over 2 times 4 times 6. All right. So we have 16 and 36, that's 52, minus 9, that's 43, I think, over 8 times 6, or 48. So if that's what cos of F is, then angle F is the arc cos of this. And we would find with the calculator, I've already entered this in, 26.4 degrees is your angle F. Now again, once you know angle F, or any of these angles, you now have an angle and the side across. I would suggest using sine law to finish this up. So cosine law, 2 variations, solving for a side squared or solving for an angle. Again, nothing special about ABC. It could be any variables, any letter of the alphabet. Cosine law is used when you don't have an angle and a side opposite. All right. So 2 scenarios that I've given show you how it can be used when I know 2 sides and what's called a contained angle, so I can't get that angle side pairing, or when I have a triangle with no angle information at all. That's the cosine law. It's a little harder to work with than sine law, so I'd recommend using it only if you can't use sine law.